So today we are solving a GCSE physics question that challenges the common misconception that we showed out at the beginning of the video. So James, explain the question.
So most students, they're convinced that a heavier object is going to fall quicker than a lighter object. That kind of feels right, but it's not. So this question comes up every time in the exam, and every year they just change the numbers slightly, and people get it wrong all the time. So if this is me and I'm coming at this question, I don't care that this is a stone. It could be a book or it could be a pencil, and it's kind of a trick because it tells you that the stone has a mass of 3 kilograms. Doesn't matter what mass it has.
Nope.
All objects drop at the same rate. So we can ignore this. It could be 10, it could be anything. It doesn't matter. We can just ignore this completely.
Yeah, in actual fact, the only number that we care about in this whole question is that 50 meters there.
So there's a couple of approaches that we can use to solve this for any object, whatever mass that it has.
Yeah, when I first looked at this, coming from a mathematics background, I thought SUVAT, if anybody knows about that. But that's not how we're going to approach this today, because we know most people will be looking at it in terms of energy conservation.
But if you know SUVAT, you can give it a go and you'll end up with the same bit of working at the end and the same answer.
Yeah. All right, James, you want to kick it off? What's the steps?
So if we think about energy conservation, you start off with one kind of energy and then that moves into a different store of energy. So think about what store of energy it has when it's at the top of a tall tower and what kind of energy it's going to have when it's moving faster.
Keyword there, moving, right? So when it's at the top of the tower, is it moving? No. So therefore, what type of energy are we going to have? Have a quick think about it. Yeah, if it's dropped, then at the top we're going to have our gravitational potential energy. Is that the right way around to say it?
Yeah. So I'm going to call that GPE.
And then when it's moving through the air, all of a sudden it's going to pick up a huge amount, or it's going to transfer to a huge amount of kinetic energy, right?
Exactly. So we're going to have less GPE and we're going to have more kinetic energy.
And as we know, the energy is never going to be lost or created, right? So hopefully the energy that we find at the beginning of the journey is going to match the energy at the end of the journey.
Perfect. So what you can have a go at is if we equate these two together, different notation instead of this. Sometimes we might call this one potential energy, just short for gravitational potential energy. Sometimes we might call this EK for kinetic energy, like this. Once we equate them to each other, because all of this gets transferred to this one, then we can solve it.
Awesome. What's the formula for our potential energy then?
You know this one.
Oh, Jesus Christ.
Is it?
MGH.
Yeah, perfect.
That's a good guess. And then our kinetic energy, half mv squared.
Yeah, now the magical thing here, what do we notice we've got on both sides of the equation that's actually really profound?
2 m's.
So we can cross them out.
Divide by m, divide by m.
This is such an important result. We could do hundreds of videos on this, probably won't. But that's why we can get rid of this line, because it doesn't matter what m is.
Exactly. Our pencil, our book, it's irrelevant. We fill in some numbers.
Just follow on through.
G, 9.81.
Sure.
9.81 multiplied by our height, which is 50, should be equal to half our velocity squared. If we calculate this and then double it from getting rid of the divide by 2, we will get 2 lots of 9.81 times 50 is our v squared. And then if we square root that answer, we will get an answer.
And in our heads, we can do a nice estimate here. If we think this is about 10 times 2, 20 times 2, about 1,000. So then that's going to be those people that know thirds at 10 root 10. We can see straight away it's going to be of this kind of order of magnitude. And if you solve it on a calculator, you'll get B.
All right, nice one. Job done. If that helped you with your exams, then drop a follow for more.